So now I will move to another topic, that is deterministic and random signal. Here a signal is said to be deterministic when we define the signal at all instant of time without any doubt. That means if we can give perfect definition or perfect equation of a signal, then it is said to be deterministic. So we define a deterministic signal as if there is no uncertainty with respect to the signal value at any instant of time, then the signal is said to be deterministic. For example, a sinusoidal wave. It is a picture of a graph of a sinusoidal wave. The amplitude of a sine wave can be defined at any instant of time. You can see here. Hence it is a deterministic signal. Moreover, the sine wave can be represented in equation form also. As you know, as we had discussed in our previous class, that a sine wave, if the signal is represented as xt, it can be represented by an equation as a sine omega t or a sine 2 pi t. So therefore, we can say that it is a deterministic signal. Now we move to a non-deterministic signal. A non-deterministic or random signal is one where there is an uncertainty while defining the value at any particular instant of time. If you consider this diagram, this is the diagram, then you can see that it cannot be defined at every time or at every value of t. You can see here the value of t there is fixed, but after a certain time, that means by this time, this time interval to this time interval, the amplitude of this signal is very uncertain. The ups and downs of this signal become very fluctuating. So therefore we cannot define or we cannot give the actual equation or of this signal, or we cannot relate the component of this signal, that is t and xt. We cannot define the relation between xt and t. Therefore, it is said to be a non-deterministic or random signal. So, simply you can say, if you can give any mathematical equation relating to a signal, the signal is said to be deterministic, like this. But if you cannot determine any mathematical relation for the component change in the signal, then definitely you can say the signal is a random signal. Here, the example I am showing here is for a continuous wave. But this is also true for the discrete value signal also. In this video, we are going to discuss about even and odd signal. Based on symmetry of the signal, when time is reversed, we can classify the signal into two types. The first one is even and second one is odd signal. So when we perform the time reversal and based on symmetry of the obtained signal, we can broadly classify signal in these two types. I will first explain even signal and then odd. The signal which remain identical under folding operations are called as even signal. So when we perform the folding operation, which is also called as time reversal or reflection of the signal, and the signal remains same, then we call such signal as even signal. Let's try to understand this in terms of symmetry. A signal which is symmetrical or mirror image about the y-axis are called as even signal. Let's say the original signal is xt and we will perform the time reversal. So the obtained signal will be x of minus t, because you should know in the time reversal t becomes negative. And according to the definition of even signal, x of minus t equals to xt. So the condition of even signal is xt equals to x of minus t for all t. This is your condition of an even signal. Now we will see few examples of even signal. In the first example of even signal, we have a triangular wave xt. When we perform the time reversal, you will have x of minus t, which is exactly same with the signal xt. That means if you perform a time reversal or folding with this signal, after time reversal the signal will be looks like exactly same or identical with the previous one. So it is an example of even signal. This is another example of even signal. When we perform the time reversal with this signal, the signal becomes x of minus t, but it is exactly same or identical with the previous one. This is the another example of cosine wave. Here xt equals to cos of omega t. In this case, it is also a even signal, because when we plot x of minus t in place of t, we have x of minus t equals to cos of minus omega t. And you should know a formula that cos of minus theta equals to cos theta. Therefore, it becomes cos of omega t, which is exactly equal to xt. So therefore, it is also a even signal. If you look out the waveform of this signal, you can see that the waveform is symmetrical about the y-axis. This is the y-axis and the signal is exactly symmetrical with about the y-axis. Now we will move on to odd signal. A signal which does not remain identical under folding operation is called a odd signal. So x of t equals to x of minus t. This condition is not when true. This is not true. For this case, or when we can say x of minus t, or we can say x of t not equals to x of minus t. In that case, the signal is called odd signal. Odd signal are antisymmetrical about the x-axis. Now let's us try to understand what do you mean by antisymmetrical signal. Here we will perform the time reversal of a signal xt and the signal xt, this signal is having the waveform like this. So when we perform the time reversal of this signal, this means when we try to find out x of minus t, we will find the waveform will be like this. And it represents as x of t equals to minus of x of minus t. Or we can say that this is the condition of odd signal. And if we talk about t equals to 0, then x of 0, that is equal to minus of x of minus 0. And this is possible only when x of 0 equals to 0. Therefore, an odd signal must be 0 at time t equals to 0. This is the most important property of the odd signal. The second property will be the average or the mean value of the odd signal is equal to 0. So the most important property is when t equals to 0, the odd signal is 0. And the second property is the mean or DC value of a odd signal is also 0. And the odd signal will always pass through the origin. Now the example of the odd signal is a sine wave. Let's xt equals to sine of omega t. If we perform a time reversal, then it must be sine of minus omega t, which is equal to minus of sine omega t. That is exactly of x of minus t. So the condition of odd signal will be satisfied. If you look at the signal or look at the graph of an odd signal, so we can easily find out that the sine function will be passing through the origin. This is the origin, and the sine function will pass through the origin. Here we have to remember some important points. Number 1, sum of two or more even function or product of two or more even function or product of even number of odd function results a even function. I am talking about three functions. One is t square, another one t to the power 4, and another one cos of omega t. If you check by yourself, then you can find all these three functions are example of even function individually. Now, according to this rule or formula, sum of two or more even function. That means if we add these three functions, it would be a even function. Or product of these three functions will be also an even function. But product of these two functions will be also an even function. If you check by yourself, you can see that here t cube is an odd function. Similarly, sine omega t is also an odd function. But when you product these two items, as the formula will say, product of even number of odd function results a even function. Therefore, these two function will result also a even function. Now we move to second formula. Sum of two two or more odd function or product of odd number of odd function results an odd function. For example, t cube plus t to the power 7 plus sin t is an example of odd function. All these three functions individually a odd function. Therefore, sum of these three functions will be a odd function. Or t cube sin t and sin 2t will be a odd function also. So the next property is any signal can be represented as sum of odd and even signal if we have a general signal. Let's say the signal is xt and this general signal can be represented as sum of odd and even parts. The odd part will be represented as x of ot and the even part will be x of et. And the sum of these two parts of the signal xt will result the signal itself. So this is all for this lecture. See you in the next class. Thank you.